Alright, today you are working with symmetry. And there are two types of symmetry that you're dealing with. One is line symmetry. If I folded this in half, would both sides of this piece of paper look exactly the same? Yes. So if I folded it in half that way, they would look the same. If I folded it in half this way, would they be the same? Yes, they would have two lines of symmetry, one vertical, one horizontal. If it was a square, you could actually have the diagonals, but since it's a rectangle, if I tried to fold it, there would be overlap. So lines of symmetry are not there on a rectangle for diagonal lines. If it's like a perfect or regular pentagon, you would have every point, you'd have three lines of symmetry. So a lot of times you can do it from each one of the points on it, a clover leaf or things like that. If they're drawn the exact same way, it would have however many sides there are. For Lance, for you, for the Cowboys star, you'd have 5 lines of symmetry from each point of the star. You could split it and it would look the same on each side. But if I put a mark here, if I just put a dot right up here and then folded it, it would no longer have the line of symmetry unless we split that mark in half. If I put my name across here, it couldn't have symmetry because it wouldn't look the same on both sides. So line symmetry has to look exactly the same. Line paper, you cannot fold it and have symmetry because it has holes on one side and the lines are different on both. So that's why I'm using computer paper. The last thing is rotational symmetry. If I turn this like this, it doesn't look exactly the same, but I can turn it halfway around and it would look exactly the same. That's rotational symmetry. That when I turn it, I can make it look exactly the same both ways. So that's the two symmetries you're dealing with today.